a lengthy word problem. And whenever we encounter word problems, all we have to do is translate the words into equations. I can't stress this enough. Make sure to do this on the AMC 10 test. I will do this on the AMC 10 test. This is extremely, extremely important. Okay, so as you see here, we can start. It says the arithmetic mean, and we're first gonna I'm gonna explain what the arithmetic mean is. So the arithmetic mean is basically just mean. It's a fancy way of saying mean, and arithmetic is basically calculations, subtraction, addition, all of that. And the mean is basically the sum of all numbers, and then we divide by the number of numbers. So to find the average. So the average is the mean is basically average. Okay, of the 9 numbers. So we know there's 9 numbers in the set, and we have to divide by 9 to find the mean. So the sum of the numbers divided by 9, which is the number of numbers, and we find the mean. So in the set, 999, 999, on and on and on, is a 9-digit number m. So we know that we find the arithmetic mean of this set, and we get a 9-digit number m, all of whose digits are distinct. The number m does not contain the digit what. So I want to make sure to do this AMC 10 problem the fastest and most clear way as possible. So most simple to understand, easy way as possible. Okay, so we have 9 plus 99 plus 999, and all of these are divisible by what? 9. As you see here, we can go on and on and on until there is the number 999,999,999. So basically 9 nines. And I'll put the commas here as well. Okay, so what are they all divisible by? 9. Okay, so that's one common thing. They're all divisible by 9. And how can we use that to our advantage? Well, if we factor out 9, so we have 9 times 1 plus 11 plus 101, 11 plus all the way down here, which is just 9 11s. No, 9 ones. Sorry. And then we make sure to include the dots. Okay, and we're all dividing this by 9, and we get m. Well, if we're dividing this by 9, we can cancel something out. And as you see here, we can cancel the 9s out. So we cancel the 9 in the denominator and also the 9 in the numerator, and we get 1 plus 11 plus 111 all the way up to that big number. So we have that big number, which is equal to m. And now we can actually see what the problem is saying. M's digits are distinct. Okay, so if we format this a little bit differently, we have 1, 11, 101, and then 1,000 and 111, and we can keep on going. And as you see here, if we do addition tower, as you see here, we have all the way, we have 9 numbers. So we have 9 numbers until this very large number. And if we add all the unit digits, we'll get 9. We'll get 9 because there are 9 numbers, and they all have 1 in the units digit. Okay. And for those of you that haven't watched this channel, we use unit digits here. We don't use ones digits to be more formal. And continue on the problem. We have 8 tens digits, 8 ones that are into tens digit. And if we add that together, we have 8. And then as you see here, if we continue the pattern, we have 9 in the units digit, 8 in the tens digit, 7 in the hundreds digit, all the way to the 100 millionth digit. Okay, so in the hundreds million digit, we'll have 1. And the reason why it will have 1 is because this is the largest number and it's the only one that has 100 million. Okay, so we have here this big number. That's the arithmetic sum. It's a 9-digit number. We can check our work. And the only digit that it doesn't contain is 0.